Alright, so we're gonna do another continuation of the lesson that we did yesterday. I did it yesterday. Probably heard it in one day, you guys. So we're gonna talk about something called the discriminant. So if you remember the quadratic formula being negative b plus minus root squared b squared minus 4ac. And if you remember, I showed you that if this whole thing, if anything under this bracket is a negative, we're gonna have an imaginary root. Imaginary. And if it's positive, we're going to have a real root. So, we're going to talk about something called the discriminant. So, the discriminant is basically the value of this. For example, if we have, let's say if this is equal to a negative number. Let's say negative 10. So, what we're going to have in this radical is going to be negative 10. So, you can tell right away, for any value that is below 0, if okay, so I'm going to write it out here. It's below 0, this is going to give you imaginary roots. I'm just going to write that. However, if b squared minus 4ac equals to 0, what does that mean? This means this radical is going to be 0. So that means you just have nothing. So you're essentially going to be b squared over 2a. It's all you're going to have. And what is this? This is a definite value. Because remember, all your plus minus, this part is gone. So you don't have two values anymore. So what does that mean? That means you only have one root. So when we look at this, when we look at all the options, this means we'll have two equal roots. And then obviously when you have b squared minus 4ac that's bigger than 0, that's obviously the most common cases, you're going to have two real roots. So whenever you actually write it out, when your teacher asks you, hey look, use the discriminant and see how many roots we have, you either write two imaginary roots, two equal real roots, or one real root, or you'll write two distinct real roots. And that is basically how you get to that. So now let's go ahead and move on to 2.3, 2.4, something I believe. It doesn't really matter. We're going to be learning how to add and subtract and do all these fun things with radicals. So back a while ago, we learned radicals and we learned how to simplify it and multiply them together. Now we're going to learn how to add them. So when we look at these radicals, the first thing we're going to do is actually simplify it because, well, we can't do anything right now. So 12 square root 12. This is actually go ahead and give you 2 root 3. 2 root 3. 18 can be broken down into 3 root 2. And then 27 can be broken down into 3 root 3. And then 8 can be broken down into 2 root 2. Now, we can only add them together if their square root part is the same. So for example, 2 root 3 and negative 3 root 3, they have the same square root part. They have the same radical part being root 3. We can go ahead and do 2 minus 3. What is that? Negative 1. And then we can not write the negative 1 at all. So that's going to be negative root 3. And then plus 3 plus 2, that's going to be 5. And then we can't get rid of the radical part. That's plus 2. So we can remember, we can only ever add the radicals if they are the same. If we can only add the terms together if they have the same radical part. If they don't, we can't do anything about it. Now let's quickly speed through b. Remember that root 3 root 20 is not fully simplified because we can take another 4 out of it. So 4, when we take the 4 out, it's 2. So 3 times 2 is 6, and then we have 6 root 5 minus, that is 2 root 3 plus 6, and then out of 45 we can take out a 9, and that would be 3 root 5. So 6 times 3, that's 18 root 5. Finally, we combine these together. 4 minus 2, 2 root 3. 6 root 5 plus 18, that is what, 24? Yeah, 24 root 5. And then that is our answer. Now let's go ahead and get to multiplying a radical by a binomial. So just like how you would do a regular, an expansion, like x plus 1 plus y, it's gonna be like x plus xy. You distribute it to every term. You're gonna do the same thing. So essentially, we're gonna have 3 root 2 times 2 root 6 plus 3 root 2 root 10. So this is what we're going to have, essentially. And now we multiply the part out. So remember what we learned earlier. We just multiply the number part, so it's 6, and then multiply this part, 12, and then plus that one we just really can't multiply. There's no number part to root 10, so that's 20. And now we go ahead and simplify this even further. So 12 root 3 plus 3, and then you 4 times 42, so 6 root 5. And remember, look at it, we can't add anything together, so therefore this is our final answer. Now, binomial multiplication, I actually showed you this a little earlier, if you remember, which I assume many of you actually don't, because that was a long time ago. But I'm still gonna show you how to do it. So we're gonna do it just like a regular binomial. So we're gonna FOIL, basically FOIL. So first term, we're gonna be like 3 root 2 times 4 root 2. First, and then we have what is it? Outside, which is plus. Okay, you know what? This is inefficient. I'm just gonna directly multiply it together so you guys can understand what's going on. So we'll have 12 root 4, and then root 4 is 2, so we'll have 24 as our first term, plus, and then root 3, that's gonna give us negative 9 root 10, and then plus 4, 4 times 4, that's 16 root 10, 16 root 10, and then minus 12 root 25. So that's going to give us, so unlike a binomial, we'll actually be able to collect the terms. Well, more terms. So negative 9 plus 16, that's 7. 7 root 10. And remember, negative 12 times 5, that's negative 60. So 24 minus 60, you're going to have negative 36. So finally, your answer is going to be negative 36 plus 7 root 10. So essentially, for every one of these, you're going to have two terms. One term being the radical part, and one term being the full whole number part. And then let's go ahead and look at how do we simplify fraction with a radical in the denominator. So we're going to go ahead and introduce the idea of rationalizing a number. So usually when we have a square root in the denominator, it's really stupidly hard. So whenever we divide something by a stupidly long decimal, it's going to be very, very weird and very, very hard for us to do, even with a calculator. We might be missing steps, we might be rounding stuff around. So usually we want the square root to be at the top. So how do we get the square root to go on the top though? So what happens if I multiply this by square root 2 over square root 2? Because technically this is equal to 1, and I can multiply 1 to it, right? I don't break any math laws. So now, this is going to go ahead and give you root 2, and this root 2, it's going to cancel out with this one. So now, this is going to be 2. So 3 times 2, that's going to be 6. So now it becomes root 2 over 6. And finally, we have completely got rid of the radical in the bottom, and now we only have a radical at the top, and we have finished it. And now we're multiplying by the conjugate binomials. We're still gonna use FOIL. However, you might remember this as the difference of squares. So we have the first term, 7 times 7. Well, square root 7 times square root 7 is gonna give you 7, and then minus 2 root 21 plus 2 root 21. So this cancels out, and then you will have minus 4 root 9, and that's gonna give you 7 minus 4 times 3, which is 12, and then negative 5. So essentially, when you have, when you have this difference of squares, you're going to get one value, and one term, one value only. So that's negative 5 in this case. And now we talk about fully rationalization when we have a binomial denominator. So we introduce ourselves to multiplying by the conjugate. And we realize whenever we multiply by the conjugate, we will have a number. We'll have a number value. For this one, it was -5, right? So whenever we multiply that by its conjugate, we're going to have an actual number value. So in this case, we're trying to get rid of the radicals in the bottom. So what is the conjugate of this? Well, 2 plus 3 plus root 3, I'm sorry. So 2 root 6 plus root 3, that is going to be the conjugate. So we switch the signs, and that's our conjugate. So let's go ahead and write this out and see how it works. So 5 over 2 root 6 minus root 3 multiplied by 2 root 6 plus 3 over 2 root 6 plus 3. So now we will realize, hey, look at this. This was a difference of squares that we dealt with earlier. What is this? What is the answer of this? Well, it's going to be 2 root 6. Oh, sorry, I forgot the square root here. It's going to be 2 root 6 times 2 root 6. So that's going to give us 4 root 36, which is 24. And then minus root 3 plus root 3, that's going to give you -3. And you know what that means? We can go ahead and do this, which is 21. So we're done with the, well, we're done with the denominator over 21. So now we're just going to do the top. So now the entire lesson actually leads up to this point where we're going to try to rationalize it. So we learned, we learned how to do, oh wait, not this part. We learned how to multiply a radical binomial, and we learned about this. We learned about rationalizing. We learned about conjugates. And finally, it all leads up to this moment. So on the bottom we have 21. Now 5 times 2 root 6, that's going to give you 10 root 6 plus 5 root 3. That was the distributive property, if you don't remember. So you're distributing that. And now this, we look at it. Can we simplify it further? No. We can common factor the top, but it doesn't really matter. It doesn't cancel anything out. So here we have our most simplified form. So I was going to add some practice for you to do this class, but I assume that, hey guys, it's a pretty easy class, so I think we have no problem with it. I will, however, next class, I will add a bit of word problem from this class, so you can, suit yourself and warm up your brain. But anyways, this class was really easy. If you have any problems, go ahead, email me, leave a comment, and I will help you as best I can, as best as I possibly can.